They're definitely not on it if I don't start it.
It looks so sad, doesn't
Because you're not saying this.
Oh. I tried watching the first Star Wars yesterday.
Oh, it's tough.
And fell asleep.
The first Star Wars?
Eventual minutes.
A New Hope?
Not, I guess episode 1. I like episode 1. Yeah.
Episode one. There's about 10 minutes of pool pod racing.
Yeah, there you go.
And that's about it. Is that Darth Maul lightsaber scene at the end of it? That's pretty cool. Yeah.
It's capped. And it's spoiling. Oh, I'm sorry.
I didn't actually see it, but I heard of a guy who took the episode 1 and episode 2 and episode 3 and just edited it down to one movie. That's pretty good, apparently.
Really?
Yeah. Wait, who? Yeah, you have the mug. I think you should also get a mug that says, "I hate sand."
It's cool.
How
do we get to this legend that you had up there?
Google. Google like NWS METAR abbreviations is what I Googled. All right, we got a bunch of different layers of the atmosphere. What are the two that we're most concerned with as pilots? Yeah, I guess tropopause isn't like it's a border between two layers, but yeah, tropopause and the troposphere. What happens in the troposphere? Is that
Like the leather and stuff, and good stuff.
in the troposphere?
You said the tropical.
I said the troposphere, but you heard tropopause, so I'll give you credit. Gotta work on those comms. Yeah. When you respond to what you think you're going to hear, that's called confirmation bias. Or an expectation bias, sorry. Do we need to turn the AC off for a bit? I see a lot of people putting on sweatshirts, shivering.
You don't put it.
Yeah, you gotta.
You should know.
Wait 5 minutes.
Just kidding.
If I were looking at winds aloft, and
Oh,
every 1,000 feet, like let's say at the surface, it's 25 degrees Celsius. And at 1,000 feet, it's 21 degrees Celsius. And at 2,000 feet, it's 16 degrees Celsius. How would you describe the atmosphere?
Unstable.
Unstable. What are some things that can happen in an unstable atmosphere? What kind of flying conditions might you expect? What's that?
Turbulence.
Yep, turbulence. There's stuff going up, stuff's coming down too. Okay, what else besides turbulence?
Cloudy with chance meatballs.
Cloudy, meatballs. I don't know why people are so obsessed about IKEA meatballs. I do not think that they're very good. Does anyone like IKEA meatballs?
Thank you. Good.
Yeah.
of course.
Do they?
And dog.
What Reddits are you are you in?
It was a thing,
Like
10 years ago.
really?
I think so. I will eat them. I don't know, Google
It's
it.
against your morals to eat horse,
Yeah.
as long as it's tasty. All right, so you mentioned that there might be some clouds. Let's say that in addition to this unstable lapse rate, we have a temperature of, what did I say, 25 on the surface, and our dew point was 23. What might we experience.
Is
Cumulonimbus clouds, visible moisture. And if we have that turbulence with those updrafts, vertically developed clouds, I'm getting at something more specific than that. What could we encounter? Thunderstorms, yeah, because what are the three ingredients to a thunderstorm?
Lift
A lifting force,
and moisture.
moisture, and that's for rain, but an unstable lapse rate. Okay. Coriolis force. It's not a real force, it's a perceived force. Could someone explain to me what we're perceiving in the Coriolis force?
it's when you move, I guess, an object, or I guess like wind over a rotating surface, it appears to curve when it's going straight.
I like that. Does everyone agree with that? Does that make sense? Oh, we described what an unstable lapse rate is. What would a stable lapse rate look like?
Great, that was-
Okay, so let's say it's 25 degrees Celsius on the surface. At 1,000 feet, it's 24. And at 2,000 feet, it's 23. And so on and so on. That would be
Unstable.
that'd be a very stable atmosphere.
Oh, it's just.
Just
minus one?
it's just a degree. It's
Okay.
standard would be 2 degrees. So this is incredibly stable. Air's not moving much at all. So what kind of conditions could we expect?
No.
No turbulence. Okay. Poor visibility. Why? Okay. What kind of pressure system do you think could cause these types of conditions? Would it be a low pressure or high pressure? High pressure. So we named some of the characteristics of a high pressure system, low visibility. What else? What kind of clouds might we see in a high pressure system? Stratiform clouds. So not vertically developed clouds because they're not rising much. If we had precipitation, what kind of precipitation would we see? Steady precipitation.
Is
Yeah.
that like big precipitation?
Doesn't necessarily mean light. I was confused by the term showery precipitation because I thought of like a shower is pretty consistent and it stays the same the whole time, but that's what steady precipitation is. In California, we tend to get steady precipitation, where it's sometimes not a lot. It could be a lot, but it's just like uniform. It's going to be raining here. It's also going to be raining in Hawthorne, and it's going to be raining in Compton, just like pretty uniformly. Showery precipitation is where it's not raining at all, and then it's raining a lot for a bit, and then that goes away, and then it's not raining, and maybe it rains some more after that. Where we find showery precipitation, what kind of pressure system?
Unstable.
Yes, that would be a description of it. Low pressure system. So what conditions for low pressure systems? Like what would you see in a low pressure system? What kind of weather?
Clear.
Possibly turbulence, um, clear visibility. Why? Yeah, unless it's raining, then you probably won't be able to see much, but you'd be more likely to see clear visibility.
Vertical.
Vertically developed clouds, showery precipitation. Cool.
What's the big thing?
Yeah. If I were flying from, let's say, Boise to, I don't know, somewhere over here between Gillette and Casper. If I were flying from west to east, terrain notwithstanding, should I go to the north or should I go to the south? Why? Yeah, we can get a tailwind. If we go north, though, we might be like along this cold front this whole time, so maybe that wouldn't be so good. But then also, if we go to the south, we're going to cross this trough. Yeah, there's always variables, but if we do go to the north, we would tend to get a tailwind. We get a headwind over here, opposite for a low pressure system. Okay. Types of flying that we're doing, we don't usually have the luxury of choosing. Topography tends to choose for us. And we're not usually flying so many hundreds of miles that we're flying around an entire pressure system. We have some mountains over here. This is like a map depiction. This is north, that's south. And we got some wind coming from this direction. And we're flying from west to east. What would we experience before we cross the mountains? Before we cross the mountains, yeah.
Wind.
Yeah, we're definitely gonna have wind. What specifically about the wind? Updrafts, why? Yeah,
Upslope.
yeah. You pointed a hair dryer at this, it would go up like that. Okay, so then what will we experience upon crossing the mountains on the other side? Probably downdrafts, maybe some turbulence because it's just like after the relative wind blows over a wing, kind of comes down and like creates some vortexes. Well, that's gonna happen too. Um, yeah, so there'll be downdrafts, maybe a little bit of turbulence. So what if we were crossing it from the other side? Like, let's say those mountains are 6,000 feet. We're taking off from a desert airport that's basically, sea level. We got to climb over those mountains. What kind of conditions might we see if we're trying to climb over those mountains east to west? Yeah, getting to 8,000 feet would sure be helpful. Would it be, let's put yourself in the other situation. We're going west to east. Do you think the climb would be easy going from west to east?
No.
From west to east would probably be a little, oh no,
No, I thought it'd be more bumpy.
no, it'd be harder to get there because you're
It
coming.
would be easier because you'd have updrafts to help you. You have a tailwind, so you'd be going faster, I suppose. So your ground speed would be faster, you need more distance, but you'd also have updrafts that would help you climb over. So if we need to climb over the mountains the other direction, what would you expect? Bad climb. You're gonna be fighting these downdrafts. I've experienced that a few times where I had to, even like 20, 30 miles away from these mountains, you're getting these, what is it called? when wind goes over a mountain and then kind of does this afterward. What's that called? No, what is wake turbulence? Yeah, wingtip vortices. So this is about mountain wind going over a mountain. So what?
Oscillation.
It is an oscillation. It's called mountain waves. And they go, so right afterward, it kind of like buffets a little bit, churns it up, but even like 100, 200 miles afterward, it's still going up and down like this. So if you're going into the wind, trying to cross mountains, you're gonna probably be fighting some strong downdrafts. You might need to go away from the mountains and climb hard because to get a couple thousand feet above those mountains. Why'd you say 2,000 feet?
Isn't that just the standard for above the mountains?
It is. Do you know
Like,
why?
Give us like buffer between us. Is that like how high you need to go to get above like the air that's speeding up over the or is the air speeding up?
I think you gave two different half answers. Laura, do you want to say something?
I think he was thinking about wildlife. Is that what he was thinking about?
No, I mean, minimum altitude for crossing mountains suggested is 2,000 feet. One would be for like gliding reasons. There's not really any great spots to land in the mountains. But the other one would be, yeah, we can be further away from that air that's being affected by the mountains.
Does the mountain create any kind of what's it?
Venturi effect?
Venturi, yeah.
I mean, really anything can. So like, you ever seen this? A piece of paper accelerates some air over it. It creates low pressure and the paper rises. It's because the higher pressure air underneath that is kind of acting as the top part of a venturi. So anything can do that, but it's not meaningful. It's more just it's called orographic lifting. Orographic meaning like topographical.
You should have did that on the first.
Yeah.
What?
The paper thing.
Just like the
I forgot about that. Okay, low level wind shear. What is wind shear?
When there's a change in wind, it's like more.
Change in wind direction and or speed. I also like Michael's answer. Do you want to show everyone your answer? Yeah. Okay, so where is wind shear most dangerous? Close to the ground. So let's say you are on final, you're about to land, and tower says attention all aircraft, low level wind shear reported 100 feet above the airport, 100 feet above the runway, change 40-degree change in direction, 15-degree change in speed, or 15 knot change in speed. What are your options?
Go around.
Go around, you can go around, and then what?
Either wait for it to die down or land at another airport.
Just like stay circling above the airport until it dies down. Yeah, that is an option. You could, did you say another airport too? Yeah, you could go to another airport. If you're not confident you can land in a situation like that, you've never landed like that before, maybe you are on you're cross country solo and you get there and you go, oh, this is not good for me. You could go to a different airport that has better conditions. What's another option?
That's cautious.
Just be extra cautious. Tell me how you would be extra cautious.
I mean, if you attempt it and it's like not the go around.
Yeah, you can always attempt it, knowing, like, basically planning, I'm going to go around unless I magically am able to keep this stable. You're expecting at any second, I'm gonna throw the throttle in and go. Okay. Speaking of which, when you go around, what do you do with your flaps? You go to flaps 1. You're supposed to communicate too with the tower. When do you communicate with the tower?
You're safe to.
Yeah, aviate, navigate, communicate. So communicate is last. So get yourself out of the situation. Full throttle as soon as you have the plane under control. Flaps 2, trim, flaps 1, trim. And then when would you take flaps 1 out?
500.
At 500 feet, what? 500 feet?
Yeah, that's it.
Okay, so 500 feet MSL, and I heard 400 feet. Why am I hearing two different numbers that are both correct, kind of?
That's where at
Yeah, so 400 feet AGL is when you take your flaps out. I don't want you to get stuck to 500, just thinking 500 feet because that's what Torrance is, because then you'll go to an airport. Obviously, if it was like the airport elevation is 1700, you're not going to make that mistake. But if the airport elevation is 360, then you might make that mistake. So it's 400 feet AGL. Okay, so let's say we want to try it. Proceed with caution. Have any of your instructors talk to you about how you can better prepare to land when you have wind shear? Do you have any guesses on what you might do?
Which one speed up, increase your speed,
Increase your speed. Why?
because you wouldn't know where the wind is coming from, so wind shear like slows the plane down.
Well, it can, or it could speed it up.
I mean, the slower you are. Rapid movements you make, it's your weight. Like you have zero control of the airplane, right? So you want to go faster. It give you a little.
That's also a good point. Primary reason you would want to go faster, maybe flaps 2 instead of flaps 3, because flaps 3 really makes you sink. Is yeah, what produces lift again? Like our relative wind. Is our relative wind our ground speed? No. So our indicated airspeed is a pretty close approximation of what our relative wind is. So if we have a 15 knot headwind and we have an indicated airspeed of 65, so we're coming into land, and then all of a sudden that goes away, that we have that wind shear, it shifts to a crosswind or a tailwind, or it just kind of goes away. Then all of a sudden we're not going 65, we're going 50. So going at a faster approach speed, maybe in the mid upper 70s even, until we get, close and in ground effects, we'd approach faster to anticipate our lack of a headwind, change in our relative wind. Okay, cool. Microbursts are bad. Stay away from thunderstorms. You will never be able to climb out of it. Some airports are starting to have microburst detectors, where you're not going to have it at any general aviation airport. What stage of a thunderstorm does a microburst happen?
Dissipating.
Dissipating stage. How long do they tend to last in a range? 5 to 15 minutes. Why does a microburst happen?
weather.
Yeah, it's out to get us.
Heavy, like it can't hold it in.
Yeah, so during the second stage of a thunderstorm, which is called what again? A mature stage, we have updrafts and downdrafts holding this relatively heavy moisture in there, and then dissipating stage, do we have those updrafts anymore?
No.
No, so all that rain can kind of come down all at the same time with the downdrafts and increase the downdrafts. And yeah, what would be the indication? Like, let's say you're an instrument rated pilot and you're flying through the rain. What would be an indication that maybe you are approaching a microburst?
You see, like, if you're close to the ground, you can see the wind blowing the ground.
Okay. Yeah, that's true. In instrument conditions, you're probably not going to be able to see the ground all that well.
I guess,
What would be an instrument like inside the plane? What would be an indication that maybe you are approaching a microburst? What's that?
the wind direction.
You say more.
Yes,
Yeah.
you're gonna get really strong.
Yes. Here's our cloud. Here's our microburst. It's gonna go out like this when it hits the ground. All of that downdraft has to go somewhere. So you would start with a headwind. So you get a ever increasing headwind. So if you're coming in at 70 knots or whatever airspeed you're coming in, and then all of a sudden you're doing 110 and you've pulled power out and your airspeed is still increasing, well then maybe you're entering a microburst. Could be. Yeah. Yeah, you have increasing headwind. What would happen when you get in the middle of it? If you didn't crash,
Strong downdraft.
strong downdraft,
Lose lift.
and then a tailwind at the end. It's just like a faucet going down and hitting your sink. It just goes out in all directions.
So with our planes, our cruising speed is like 90. And microbursts might be like 90 knots. Basically like stationary over the ground at that point.
If we were able to maintain 90, but we probably, yeah, I'd suppose if you had a 90 knot headwind and you were pitching for 90 knots, then you would be able to just stay where you are. But more than likely, you would just start going super, super fast. But yeah, I've flown backwards before. Doesn't happen very often, but occasionally out in the practice area, you'll get like 40, high 40s or even 50 knot winds, and you just put that thing in slow flight, flaps 3, and just get it right near stall, and then you start going backwards. It can be kind of fun.
That's crazy. That's like surveying.
Yeah.
That's fun. Yeah, that's what I asked essentially. Yeah. I was like, yeah, are you stationary over the ground? Because if the headwind was faster than your plane is able to go, then yeah, you go backwards over the ground. Does that make sense? Yeah.
What's
So if it's a
relative-
strong- If it's a strong enough microburst, you wouldn't be able to get into it.
I wouldn't test that theory.
I mean, you get wrecked as soon as you turn.
Not necessarily. I've turned in pretty high winds. It just changes. I took off in a 38 knot headwind and then I had to turn and no, it just meant I go, okay, full throttle and I'm in the air. And then you don't go very fast across the ground. And then as you turn, your uh your wind is changing to more of a crosswind. So then as you're turning, you aren't getting that resistance anymore. So thrust is taking over and your relative wind's coming this direction. I guess if you were in a 40 knot wind and then you just banked 90 degrees, then you would like drop a lot. But yeah, if you're turning in a heavy wind, basically you just you're not going to climb as much, but you control your airspeed with your pitch. So instead of being not pitched much at all because we have so much wind speed, then you'd be pitching a little bit more. Maybe you would stop climbing as aggressively, but yeah, it's no big deal. Blah, blah, blah. Okay. What's the standard convergence rate of a temperature and dew point spread? Huh?
2.5 degrees Celsius.
Okay, so what does that mean?
That's like is it at that's like when they meet, I guess. right?
Okay, so give me an example. No, I'm gonna stick with you. Give me an
That's like-
example.
So your temperature was, I guess, 25 degrees Celsius, and your dew point was 20 degrees Celsius. That they meet at you know, you know.
I do, and I think maybe you do too, but you're not saying the words. So they would meet,
No,
they would
but
meet
like
where?
At 4, 5.
Okay, so 2.5 degrees Celsius per what? Per 1,000 feet. Does that help, Mason?
I mean, it's like, okay, so that's when they both be like, that's you're saying that's when just the temperature's rising is like just the temperatures.
I'm saying that the temperature is going down and the dew point is going up, and they're meeting at 2.5 degrees Celsius per 1,000 feet. So if you have a difference of 5 degrees between the two of them, and you go up 2,000 feet, they're going to be the same.
Yeah, but so that is where they're
Yeah. Where is?
okay. It was so this was so 2,000 feet, but it's not
Yeah.
like that's just where the like
Where the temperature and the
varies.
dew point converge, where they meet. That's why it's called a convergence rate. Yeah, why is that information handy potentially?
So where the cloud like estimate the cloud base could be.
Great.
So as you're going up in altitude, your dew point is increasing and your temperature is decreasing.
Yes.
That's really.
Yeah. Okay, what's fog? Not a trick question. What is it? It sure is. Is it any different from a cloud?
No.
No, it's just on the surface. What are some different types of fog? Anyone shout out a different type of fog?
You have here, right?
Advection fog. And what causes that?
Okay, I'm right, that's what happens here.
Yeah, do you know how it happens?
When warmer air from like water comes from like goes over cold land,
Mm-hmm.
polar land.
Yeah, so what time of What time would
night.
that happen most? Yeah, at night. Why does it happen at night most often?
That's when. The land has to like cool down and like the winds are a little bit more. Calm in the way.
Yeah, well, you're right that the land doesn't hold heat very well, so it would cool down. And then that warm, moist air would mix with that colder air, and the temperature and dew point would come to meet. Um, yeah, advection fog. What else? Steam fog. Here to tell us how that works?
It's like it comes from like the hot water, it was like warm water and then. Like cold air.
Warm water, cold air, steam fog. Okay. What else? Radiation fog. How does that work?
Here we go. I just remember the word.
Okay. Anyone want to give it a shot? Radiation fog?
Isn't that when? I think I remember like the picture, is it like when it's like a little pond, right? And then it's like. Just like, no, never mind.
It's basically the same thing as steam fog, but. Like heats up.
No.
Rapid due to. Surrounding regions.
What does that mean?
I don't know.
They didn't tumble in pairs.
Okay, so. When the ground cools rapidly.
Say it louder.
I don't know, I'm trying to figure it out.
I know, but say it so everyone can hear.
When the ground cools rapidly.
Okay, we have ground cooling rapidly. When would that happen?
When the sun goes down.
Yeah, at night sometime. Okay, so it's nighttime, ground's getting colder. Continue.
Due to terrestrial radiation and the surrounding air temperature reaches its dew point.
Okay, why would the surrounding air reach its dew point when the ground gets colder?
It's air warm.
Yeah, so when does visible moisture form?
The air right above the grounds cools down and so it can no longer hold the water vapor that's in it. Because it
Yes,
becomes more dense.
exactly. So just in general terms, when does visible moisture occur?
It's dew point.
When the temperature and the dew point meet. Okay, so if we have, keep going 25, it's 25 degrees Celsius on the surface. And then our dew point is 21 degrees. Okay, no visible moisture, they're not close enough. But then sun goes down and a lot of that heat dissipates, radiates away. That's why it's called radiation fog. It just cools down because it's not holding on to it anymore. So that heat goes away, and now it's 21 degrees Celsius out. What's going to happen? Fog. So the two ways we can get visible moisture is we either we put more moisture into the air so the dew point reaches the temperature, or we can lower the temperature until the molecules condense so much that it can't hold that moisture anymore and we get visible moisture. If you think about it in those terms, it's really super simple. We need a temperature and our dew point to meet, and we can do that either by lowering the temperature or increasing the amount of moisture in the air.
So
One of those two things, or usually a combination of both, is what makes that visible moisture.
So theoretically, if we just kept cooling the temperature in here down, we'd eventually get.
Absolutely, yeah. Yeah, it would squeeze out any moisture in here. I don't think it would be that much though. It's kind of sticky in here. Yeah, Mason, why aren't you doing your job, man? God,
Didn't wait.
okay. What's up, Slope Fog? Not much, what's up with you? Yeah. Smells like upslope in here.
There's blowing towards. the side. These-
Yeah. Is this concept starting to sound familiar? Could you repeat that one more time?
Air is going towards the side.
What kind of air? Is it warm and moist?
Air that is warmer than the dew point.
Okay,
It's going towards the hillside. And it's the hillside, it raises, and as it raises, it cools, which then eventually makes it meet the dew point, and the condensation goes out.
yeah, it's just wind that goes, warm moist air that goes uphill to where it's colder. So temperature goes down to meet the dew point. We get visible moisture in the form of upslope fog. All of these are just the temperature and the dew point meet for some reason. Steam fog, we already talked about that. Hot water, cold air, temperature, dew point meet. Ice fog, this is a mystery, this is magic. But it's the same type of thing as steam fog, but it's when it's super duper cold.
It's basically like or cirrus.
Yeah, it goes directly into ice crystals. They got a temperature and dew point meet, but it's already like way below freezing, so it just turns into ice crystals. Okay. What are the classifications of clouds?
So like fine.
Low, middle, high, and cumulus, or vertically developed clouds. Low, middle, high, and vertically developed. We got a little. Here's our little depiction. Most important ones. What kind of cloud is this depicting? Okay. If it didn't have rain, what would it be? Yeah, cumulus. Okay. Uh, what is this? And if it didn't have rain, just stratus. What kind of pressure system would you be most likely to see stratus clouds? High pressure. High pressure, stratus clouds, low visibility, stable air, steady precipitation. And where would you find clouds like this? What kind of pressure system? A low pressure system, vertically developed clouds, showering precipitation, better visibility, not smooth flying, probably some turbulence. What's a lenticular cloud? Yeah, scary, bad. Yeah, I mentioned that. Yeah. In like a rapid moving river, sometimes there's like a little eddy where a leaf gets caught and it just stays there for forever. The winds around the current around it is moving super fast, but right on the inside, it's not moving that much at all. So it's not moving that much at all right here, but around it, the wind is just whipping around. Is that a type of stratus cloud?
Yeah.
It's not vertically developed. It is a lenticular cloud. That is the extent of my knowledge and analysis on that. No, stratus clouds would be connected to stable air. This air is not stable. Fractal clouds. Oh, fuck. Let's take a short break, just like 5 minutes, we'll be back. I'm hungry.
Yeah, sure. And we want to say that. That's it. Yeah. Yeah, thanks. All right.
Time y'all's flight today. 11? Are you getting out of class early to go pre-flight? Then go right now, go. I'll see you guys later. I'm talking about about 11:30. I'm at 3:30. Anytime after like 2 is just yeah. It's like sitting around, studying a little bit, but it's waiting.
Waiting for what?
So like anytime you have a flight, they're like 2:30, that sucks.
It was fun though.
Yeah, I guess.
Here, LAX.
Okay, like. Lawndale or?
It was the best time to have a flight like 4 days ago.
Oh, for what stuff?
I mean, nothing went out until
Yeah.
about 2 or 3 o'clock.
Yeah.
Five point seven.
You drove?
Yeah,
Where?
22nd and Patton. Okay. Oh, I'm just down the hill.
Ah, Mason.
Wait, don't you cop?
Yeah, it's.
I'm like actually close to the baseball diamond.
It's the temperature and dew point.
It's like the golf course, the
The temp.
Yep.
The two
That'd be
convergent.
like,
Convergent rate.
Point says
So,
this rate we take.
If the
Like,
temperature
we're not the
is
beach.
decreasing.
It's
by
0.2, then.
And does that mean the dew point increases by 0.5? Does it go up? Okay. More or less, yes.
Okay, yeah, it's all that same.
Yeah.
Day,
Huh?
It's like you figure out sometime.
Would you still fly tomorrow morning, even though I have my vacation?
No.
Oh, because there's still.
Get rid of it. You guys, ever opened up your freezer and a whole bunch of like clouds come out? Another example of warm air with a certain amount of moisture in it meets cold air. That's why you see that stuff.
That was the. When the door's shut, do you think that does it only happen when the door opens?
Well, it's when we have that warm, moist air that has more moisture in it. Or meets that, cools off, makes that steam. Okay, someone tell me what happens in a warm front.
Warm air comes in over that cold air.
Why does it go over cold air?
Warm air rises,
It rises why?
because it's denser.
Warm air is denser and that's why it
Warm air is not
rises?
as dense,
Warm air is not as dense.
lighter,
Uh-huh,
so it goes over that cold air.
okay. Are warm fronts usually cold or are warm fronts usually cold? Are warm fronts usually fast or slow? Slower. Okay. And what about this being depicted here? Is this a cold front?
No,
No, what is it?
What's it called? Yeah.
Occluded.
Occluded, that's what I meant.
No, I see how you got there, but this isn't a. So we got a warm front, this is a warm front, and I asked, is this a cold front right here? It's just cold air, yeah. Relatively stationary. What happens in a cold front? Not John? Or Laura?
Cold air comes in,
Okay,
denser than the warmer, so it goes under it, mix under it.
how would you describe the effect?
Unstable.
Unstable, yeah, why?
Because the cold air creates unstable air, and you know, warmer on top of it.
It has to do with the motion that's happening. But I said it was like a snowplow. Would that do anything?
Yeah, it's like cutting through that warm and yeah.
Yeah, so pushes all this shit up. When you have warm, moist air going into getting forced to go upward, creates unstable lapse rates, you got moisture, maybe we'll get thunderstorms. You have a lifting force right here, the cold air, that cold front is a lifting force.
Seems like the crazy weather with the cold fronts, or with the warm fronts, you just get.
Think about which is less violent.
Yeah,
Warm air just kind of going over the top slowly, or fast air getting rammed and pushed up.
right.
So this is just more gradual. And where the warm and cold air meets, we're gonna have that convergence of temperature and dew point. We're gonna get some precipitation probably. But yeah, it just slides over nice and easy. With a cold front, it's pushing all of this stuff upward and over.
So you can still get inclement weather with the warm front.
Yeah. It's just not gonna be as violent way.
Yeah.
You can also get thunderstorms in a warm front. All of this stuff is before any of these slides, you could put the word usually. Usually, when the forces of two air masses are equal, this happens. Okay, stationary front is when they're evenly matched. They don't really go anywhere. Maybe they slide vertically or slide across from each other, but they kind of stay in the same spot. Occluded front, we talked about. What happens in an occluded front?
It's both.
It's both.
Yeah, both kinds of features from the lower and cold front. You have your warm front, yeah. And then your cold front, which is fast and catches up to it. And then two cold fronts, meaning all the variants.
Maybe it's just when a cold front takes over a warm front.
Yeah, that's what he said.
Oh,
That's what he said, except he said when the two cold fronts meet, well, it's the cold front that like meets the colder air that the warm front was going over. So like this. We had a warm front. We get rid of this stuff over here. We just have a regular warm front, but then a cold front comes up behind it, pushes the rest of it up. So the cold air meets the cold air and the warm air is thrown up there. We have warm front stuff over here, cold front stuff over here, and Indianapolis gets wrecked. What is convection? Huh?
Hot air rising.
What's a squall line? Line of thunderstorms.
What's a ridge?
What's a ridge?
Uh-huh.
Anyone want to take that?
Pressure or no?
What's that?
A line of high pressure air.
Yeah,
Oh,
so it's the opposite of what? A trough. You don't see them very often.
A ridge?
Like, you know, like the
No,
top,
the trough has, oh yeah.
like, you know, like the top has like the orange broken lines.
Uh-huh.
Does a ridge have like lines or color?
Where
Trough is TROFF?
TROUGH, isn't it? TROUGH. Ridge, here we go. It's yellow mountains, Bart Simpson hair. This.
Or it seems
Yeah, Bart Simpson hair.
line of low.
A trough is a line of low pressure. So when you're studying, I mean, this is gonna sound like how I tell my parents how to do stuff on their iPhone. It's gonna sound very, very obvious, but not everyone does it. When you're studying, if you have a question of what is that, you type in what is that on Google, and then probably you're gonna come across resources like this where you can go, oh yeah, here are all these symbols. Maybe you'll click on a different one and it has even more or different ones. Do a little bit of research. Don't just use the resources I'm giving you. Search for stuff. Yeah. Oh, this is unrelated. Um, but I realized that Amara asked me a question. I realized I should probably tell everyone. So who here has done their King School or is like mostly done with it? Yeah? Okay. So you finished it or you're gonna finish it soon. And you answer all the questions at the end of each lesson. Da, 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 da. How many of you have done the questions in the question bank? There's like 850 questions. It says questions and test prep at the bottom. Have any of you even looked at that? One, two, okay, couple of you. Those exist, and those questions in the question bank are not the questions that are at the end of each lesson. It's super frustrating when it's like, oh yeah, I'm probably ready for the test now. And then I go to the review question. It's like, when did this get talked about? Go through those. Those are how you prep for your written test. And it also has a lot of this type of information. What are the characteristics of a low pressure system? How is lift produced? That kind of stuff. Read this METAR. Go through those questions and spend time with it. And it'll also help you identify where your weak points are, where you need to study more. Who here hasn't gotten a mentor? Okay, about half. Of the people who have gotten mentors, has it been helpful? Hell yeah. Okay. That's what I expected. If you haven't reached out to a mentor, do it. It's super, super helpful and free, and they need the hours. When I was going through it, it was like 50, but I think it's only 30 now. Or maybe it's 30 getting a class. I don't know. But they need a lot of hours, so help them out by help them help you. Yeah. Okay, what are someone tell me a kind of icing? Like structural icing. Rhyme. What's rhyme?
It's color.
Okay, to describe the color, what is the color? Yeah, it's not yellow snow. Okay,
Yellows.
why is the color kind of milky? Or frosty?
Because the second it like, it freezes instantly. So,
So,
It's traps air inside.
so it traps air inside, so it's not, well, I don't want to say the key word. What's the other kind of structural icing? Clear icing. So it's not going to be clear, like clear ice, because it freezes on impact. It has those air bubbles in there. And then we have mixed is the other kind, both of them. What's the most dangerous kind of icing? Clear icing. Why is that? It's heavier. Okay, probably less detectable too. Does the outside air temperature have to be freezing in order for icing to occur? Why?
Because of what you talking about for flying? Essentially, if we're flying close to freezing, the colder low pressure air will freeze that water. I guess.
Yeah, it cools down the surface of the wing.
Cools down the surface.
So in that potentially warmer than freezing water hits the colder surface of the wing, it could freeze. Also, we could have super cooled water droplets. What are those?
Water droplets that, or precipitation that doesn't, station nuclei.
So what does that mean?
There's nothing in the air for it to like bind to, so it stays suspended until it finds something to bind to, like your wing.
Yeah, so it gets below, it's water that's below freezing because it hasn't touched anything yet. And then when it touches something, it'll freeze. If our wing is above freezing, it might freeze for a second and then melt. So we kind of still need to have our wing be at freezing or below. Yeah. Okay. Icing, hail. How far out from a thunderstorm can hail fall? 20 miles. Okay, why? How is hail made? Updrafts, downdrafts. Can I get a non-John to explain that for me? Justin?
As the hail is forming in the cloud, it starts attaching more and more water to it. Comes back down, and goes back up. And repeat that cycle until it shoots the hail out.
Yeah, I like that. Freezes and refreezes because it's caught in a series of up and down drafts. What's the biggest hail you guys have ever seen? Like in person. Are all of you from California, never had seen weather before? You get hail out here?
Yeah.
So like, is it like 7-Eleven hail? Like it's just that?
In Tennessee, I got hurt.
Yeah?
And it was
How big was it?
smaller than golf.
Seen bigger for dogs.
I've seen hail at least the size of my fists before.
that's
Yeah.
crazy to think that that can be held up there that long.
Yeah,
That's why.
it is crazy. But Amara, you said it only lasts for like 5 minutes. Someone tell me, why would it only last for 5 minutes? Why would it be so quick?
Is it opposite the stage?
Yes, because it's being kept up in the air so long, and then once we stop having those updrafts, they're gonna fall. And it's gonna happen pretty quickly.
Takes it to South Carolina.
No, he's got like Tennessee written all over him. Well, yeah. The middle southeast, somewhere there.
No, I moved to LA like 5 years ago.
Oh.
I was born in Texas, and just Texas 5 years ago. And
Part second.
Would you guys believe that he worked at REI?
I thought you said. Or is that where you live? Oh.
Okay, refresher, what's 91,103?
That's
That's 91,3. What's 91,103? NW Crafts. And in that, we have, it tells us everything that we need to do before we fly legally as a pilot in command.
What's it stand for?
One of those NOTAMs, weather, known ATC delays, runway lengths, alternates, fuel requirements, and takeoff and landing distances. But in that NW crafts, we have to know what the weather's going to be. If we want to get a forecast or a briefing for our weather, and our flight is, I don't know, I'm going to go on a night cross country tonight. What kind of briefing can I get right now? Outlook. It's more than 6 hours.
I thought you said you were going on a flight right now.
Said this evening.
Oh,
Yeah, tonight. It's 11 o'clock right now.
that's interesting.
Yeah. In South Carolina, dinner and evening starts at 4 p.m. So I guess that was a little confusing. Okay, we get an Outlook briefing. Can I just go based on that Outlook briefing? No, what do I need to get at least to supplement that? I need to get at least an abbreviated briefing, but you could also get a standard briefing. What's the difference between an abbreviated and a standard briefing?
In 6 hours,
Yes.
and then abbreviated is like, we'll be leaving shortly. Is it 2 hours? I thought. I don't think it's number.
Functionally, what's the difference between a standard briefing and an abbreviated briefing?
Then you get everything. Just the things that have changed.
The changes. So it's, you could get a standard briefing and then an abbreviated briefing. You can get an Outlook briefing and then an abbreviated briefing. It's just saying, hey, I already have most of this information. I know about the NOTAMs and the TFRs and that the paths out of service and all that kind of stuff. Just tell me what's changed. And they'll be like, oh yeah, okay, well, now the ceiling is gonna be different, whatever. They're gonna tell you the changes in the forecast. That's it. Where can I get a weather briefing?
W. 1-800 W.
1-800 WX brief.
Fourth flight too, right?
Yeah, how would I do that? Okay,
What the?
how would I dial 1-800 WX brief? Okay, 1-800. Then what's the next number? 9 9 2. Okay, we get it. 7 4 3 3.
Mason looks so confused.
Are you joking?
Why do you only put 4 one time though? Wait,
What?
does that make sense? Wait, go ahead. Let's redo it. Go ahead. 1-800 and then 9.
Okay, W X
2. Yeah.
2. Then what?
What you mean?
What's the next number? B
Yeah,
R
so 7.
7. Okay. BR.
And then 3, 4, and then the little 3 jump. Yeah.
Wait, what's the next letter in brief? What's the next letter in brief?
4. I said 4.
You said 3, 4.
No, I said 4 and then 3.
You said 3, 4 is what you said. So 7, and then what number? Huh? What's the next letter in brief?
BRI.
I.
said 4.
3. 3.
Just say the number in your phone.
We got it. All right, is there anything else I want to say real quick? Oh, that's the quiz. Yeah, that's it.
Mason, were you saying hit the same? Yeah. Yeah, that was the same letter. That's how you would text it.
Okay.
It's,
That's what I'm at.
huh?
John understands that.
He was, I think he was thinking of how you would text the letter. So he was like if the letter on the number is the second letter.
Yeah, no.
I was like, why are you hitting it twice?
Yeah. So it's not like that. This predates texting.
Yeah.
So you would get an automated message, be like, hey, if you're dialing from a touch tone phone, yeah, it's just like a 1-800 number. Each letter corresponds to a number. You don't do it 3 times for the third
But it's
place.
like, how do they know I'm typing the W instead of the Y? You know,
They don't.
Estimated up.
Yeah.
Okay.
It's just like, hey, our phone number is 1-800-323-4467. What words can we make out of that?
Okay, so Justin, thank you, Justin. Thank you.
All right, see you guys later.
Thank you, Justin.
Thank you.
You got it to work the whole time?
Yeah,
Good. It must just have wanted your touch.
I
You get a headache.
Glad to hear.
give me the, did I not start the Zoom? I thought I did. Are you teaching the second one?